Okay, we're going to start the work now. It says, today you will explore using multiple representations to solve a word problem. 621 is about planting trees. Charles and Amy are summer interns at a state park. They are helping to plant trees in an area where there was a forest fire. Charles's uncle owns a tree nursery and is willing to donate a 3-foot tall tree that will grow 1.5 feet per year. So we have two numbers. We have 3 feet and 1.5. And it says write an equation for Charles's trees that receive the trees Charles receives in slope-intercept form. So we got to decide which one is the slope and which one is the y-intercept. If you notice how it says 1.5 feet per year, well, the feet per year is the giveaway. That feet would be the change in the y, and the year would be the change in the x. So this is going to be the slope, and the height is the start value, so that's the y-intercept. So this equation is going to be y equals the slope, which is 1.5 x, plus the start value, or y-intercept, which is 3. And that is the equation for Charles's trees. Amy goes to another nursery, but is only able to get tree seeds donated. There's a key. They're seeds, so they don't have a height. According to the seed packages, the tree will grow 1.75 feet per year. If you look at that number, 1.75 feet per year, the feet would be the change in y, and the year would be the change in x. So to write this in slope-intercept form, we say, well, that y equals, and then we use the slope, 1.75 x plus the y-intercept. And since they're seeds, they don't have an original height. They don't have a start value, so it's plus 0. If you want to be really clever, you might even use a negative number since seeds get planted underground. But we're not going to worry about that too much. Okay, Charles plants the tree, and Amy plants the seed on the same day. Amy thinks that even though her tree will be much shorter than Charles' tree for the first several years, it will eventually be taller because it grows more each year. But she does not know how many years it will take for her tree to grow as tall as Charles's tree. So here it says, just think about it. Will the trees ever be the same size? It seems likely because Amy's tree grows faster, right? 1.75 feet per year versus 1.5, but it starts out shorter. So Amy's tree is going to be catching up from behind. If so, how long will it take? Well, I see it's about 1/4 of a foot faster every year. So it has to make up 3 feet. So it would make up 1/4 of a foot every year, or 1 foot every 4 years. So it would probably take 12 years. But again, this is think about it. We don't have to answer. It's just to think about it. Okay, so now we're going to use two representations, a table and a graph, to justify the solution. All right, how tall is Charles's tree at 0 years? It's the start value of 3. And what we realize is that it goes up by 1.5 every time, so it'll be 4.5, and then it'll be 6, and then it'll be 7.5, and then it will be 9, and then it'll be 10.5, and then it will be 12, and then it'll be 13.5, and then it will be 15, and then it'll be 16.5, and then it will be 18 feet tall in 10 years. Okay. And then we look at Amy's. Amy's grows 1.75 every year, but it starts out at 0 feet tall. And then it's 1.75, and then it's 3.5, and then it's 5.25, and then it's 7 feet tall, and then it is 8.75, and then it's 10.5, and then it is 12.25, etc., etc., etc. It's going to be 14 feet tall, 15.75, and then 17.5 feet tall. So at 10 years, you can see her tree is almost caught up to Charles. It's only a ½ feet shorter now. Okay, so about how many years do the trees appear to be the same height? It's almost there. It's still got another ½ foot, and if it's making up 1/4 of a foot every year, then I guess it would be 2 more years. So if that's 10 years, then it would be 2 more years. It would be 12 years. You could continue the table if you wanted to. to figure that out. But I think we can see that if it's making up a quarter foot every year and it has a half foot left to go, that it needs to go 2 more years. So that would be 12 years. How tall will the trees be at this time? Well, we see 18 feet for Charles. In another 2 years, it's going to be 1.5. That would be 19.5 plus another 1.5, 21. So they will be 21 feet tall. Okay. All right. So that was doing it as a table. Now we're going to try to do it as a graph. And it says, remember to save your graph for later, so we'll remember that too. Graph the two equations in Desmos and find the point of intersection. So our two equations are these ones right here. So we'll use Desmos right here. I'll get rid of this, and we'll go with y equals 1.5 x plus 3. Oops. It's no good. Plus 3, and y equals 1.75 x. And we'll get back towards the origin to see where they cross. And we can see that the two lines are crossing here. Just to be sure, Charles's start at 3 feet tall, Amy's start at 0 feet tall, but at 12 years, we see that they are both 21 feet tall. Okay, so at 12 years, they're both 21 feet tall. So, graphing the two equations, they intersect at 12, 21. So, at how many years do they appear to be the same height? At 12 years. And how tall are they at this time? They are 21 feet tall. 21 feet tall. Okay, and that's it for 621.